We'll start with a silent prayer. Yes. Good morning. Everyone, I warmly welcome you all to today's session. It's wonderful to see such enthusiastic participation. To begin, it's my pleasure to introduce our esteemed speaker for the session. Dr. Anup is a distinguished professional specializing in applied artificial intelligence research and teaching. With expertise in natural language processing and text mining. He has a strong academic background complemented by practical achievements in both research and education. Dr. Hanup has successfully led numerous AI projects, resulting in publication in esteemed international journals and conferences. His effective communication of complex AI concepts has gathered positive feedback from students, highlighting his engaging teaching style. Dr. Anup adept at curriculum development, lecturing, and monitoring, having held roles such as AI research scientist, assistant professor, data scientist, and visiting faculty and reputable institution globally. He holds a PhD and MPhil in Artificial Intelligence from Cochin University of Science and Technology and a postdoctoral fellowship from Queen's University, Canada. His research interest is in applied natural language processing and he is a recipient of international research grant from Mozilla Foundation and United States Agency for International Development as a part of the Responsible Computing Challenge. As a token of our appreciation and respect, we would now like to present sapling to our esteemed resource person, Dr. Anup. I invite Dr. Mary Jacob, ma'am, FDP coordinator, to kindly do the honor. Let's take this moment to express our gratitude for his presence and valuable contribution to this session. We are honored to have him with us today to share his valuable insight. With these introductions, I now hand over the session to Dr. Anup sir to share his insight to expertise. Dr. Anup sir, over to you.
Good morning, everyone. Good morning. Thank you for the detailed introduction. So, first of all, thank you for inviting me as a resource person for this wonderful activity where I could interact with the participants on various avenues of natural language processing, what I have learned during my professional association with many organizations. Just a second. So previously, I was associated with some organizations, as you could hear from my that introduction that ma'am was telling. I was associated with the Queen's University, with the Smith School of Business, where I was primarily conducting applied research in NLP. And I was also part of Etihad Airways, UAE, and Etisalat Digital, UAE, on their AI implementation projects. So what I learned from my experiences with respect to NLP, I thought of sharing it all with you, because I know NLP, even though you might have, not heard that term in very deeper sense, but all of you might have used a chat GPT, right? So chat GPT is one of the examples of an applied natural language processing area where we all are using, right? Without knowing anything about programming, we can use an AI system where you can generate literally anything. So this talk is divided into several subsections, because you will be seeing my face in the afternoon as well. So in the afternoon, we will be planning basically the hands-on sessions, because I believe, right, learning theory alone will not help you, because you need to explore things and understand how theory is connected with the hands-on. And most probably what will happen in the afternoon sessions, if you are sitting, after having a heavy lunch in an AC classroom, obviously you will be sleeping, or at least yawning very often, right? So in order to avoid that, what we will do, we will open our laptop, or I will be showing how right code can be executed. I will be sharing the code files with you so that you can execute it later if you don't have a laptop. Or they will be getting a machine in the lab, right? In the afternoon, yeah. So all of you can do your the hands-on session and see how things work, or whatever we have learned in the theory session. That is how it is planned. But in the morning session, it is primarily on the theory part, and we will also be seeing some of the application areas of NLP as well, right? So feel comfortable. This is not kind of the lecturing session that you might have attended or attending in a college, right? So there are faculties, there are people from industries that I learned from the audience. There are people from industries, faculty members, research scholars, and PG students. So feel free to discuss, right? Whenever I will be telling a term or asking some questions, at least raise your hand, or just shake your head, so that I can see that you are listening to, right? If you have a question, right, you can raise your hand and ask me the question. That is okay, absolutely okay. Be interactive. That is how we learn, right? There may be more knowledge than me for many of the faculty members sitting over here, so they can share the knowledge. That is how we grow, right? So the presentation, or today's agenda, we will be going through these parts primarily. One is the basics of data science, right? Because the audience is a mix of people who are having, professional experience, or learning experience in different domains with respect to different years of experience. I thought of setting a tone for the audience so that we all will be in the same room, and then we will learn the advanced concepts. Okay, so the first part will be the basics of data and the data science, and then we will be going through the introduction to NLP, some of the application areas of NLP, history of NLP, where it has started and where we are moving, then text processing, some of the NLP algorithms, and then machine learning for NLP, where we will be seeing the advanced architectures. That is the core part of the talk, that is the transformers. And then we will be discussing a topic called the ethics in NLP, which is very, very important, right? Because wherever I deliver sessions, I keep maybe a couple of slides on the ethical and responsible use of NLP, because that is very, very important. That is, less number of people are talking about ethics and responsible use of AI, right? So that also we will be including in the presentation, right? All good, right? Okay. So these are just basic that we are going to learn, right? Maybe these definitions you might have heard many times before during your classroom, or you might have read it somewhere, but just want to make sure that you all are agreeing to what I'm saying, right? In order to learn more things. The data is the new oil that everybody knows, right? This term, right? Data is the new oil. So what is the connection between data and oil? Have you ever thought of why data is connected with oil? Any random answers? That can be foolish answers as well, but I don't mind. You can open up and tell me what. Yeah? Both are so expensive. Excellent. Then any other answer from this side? Excellent. Then, any other answers? Just throw something. Just make the floor active. Data and exactly. Yeah, good answer. There is a process in refinement for both of these things. Yes, true. Wonderful answers. Yeah. No. So if you, I don't, I'm not very sure. Like if you haven't, I mean, or if you are following the news, maybe some decades back there were constant conflicts and fight between the countries, right? Especially the countries in the Gulf region, that belt, where countries were trying to fight each other, right? Having conflict in the name of oil, right? Why? Because oil was the richest source of income for those countries. So whoever thinks like we can have a war with them, right, to get access to their oil refineries, they can make a huge lot of money, they can sell it off and so on. So at that time, right, the costliest resource was the oil, right? And there is a refinement process, as right, somebody raised that answer. There is a refinement process where this refineries, the crude oil will be going in, and the actual products will be coming out, right? So that was costliest resource maybe 2 decades back or 3 decades back. There were countries who were fighting in the name of oil. But now if you follow the news, what is the fight or the war? Now the war is between LLMs, right? The large language models the companies are developing, right? Who have the most advanced LLM that is going to happen in each and every day, right? If you're a tech enthusiast, if you're following articles, if you're following the sources for the tech related things, what will happen? You can see like one company has published this LLM which is having these many billions of parameters. Another company the next day they will be publishing something which is more advanced, right? Even ChatGPT is getting more advanced and advanced with the different versions, right? So all these things are happening. Why this is happening? Because there is a costliest resource than oil nowadays, which is called the data, right? So now there are companies or countries are not fighting in the name of oil, rather they are fighting in the name of what? Data. Who is capturing more number of data points, who is having access to large number of data, they do have some advantages. Now, right, have you heard the term FANG? FANG companies, or now it is MANG companies? What is FANG or MANG? Yeah, F stands for Facebook, right? Previously it was Facebook. Now it is Meta, right? Then A, Amazon. Next A, there is one more A, Apple. Yeah, Apple. Then Netflix. Yes, G stands for the Google. So none of these companies are trading crude oils right now. They are not dealing with oil business. They are doing with what business? Data business, right? So you'll be surprised to know Google will be knowing more things about you than your friend or relatives or parents knowing about you, right? You should not be wondered. Because now you are in Bangalore attending an FDP. I mean, may not be, they will be knowing you are attending an FDP, but at least you are at the Kristu Jayanti location that they will be knowing, right? So Google will be recommending, or some other services will be recommending some of the interesting spots near Kristu Jayanti College for you to explore, or telling these are the best restaurants that you can try, right? So how these recommendations are coming to you, because that is, I mean, the minute details about you are getting tracked by these companies. Why they have to collect this data? Why they should do this? Why? That is their business, right? That is how they make money. They will be collecting all this data point, they will be processing it. Sometimes they will be, giving you some recommendations. Sometimes, who knows, they will be trading your data to some other third parties. The third party will be paying these companies huge amount of money, right? Again, another example, like you should not be wondering, right, if somebody from an insurance company calling you to say, hey, sir or madam, it seems like you have a high BP in your last blood checkup, right? Or you have a high cholesterol in the last blood checkup. It's right, we do have an interesting insurance policy for you. Maybe it look like you will be dying after maybe 3-4 years due to high BP. So we do have a insurance policy, like if you are paying maybe 5 lakhs this year, what will happen? Your family after your death will be getting maybe 5 crores, let's say, for example. So you will be wondering from where they have got, right, to know you have a high BP or a high cholesterol in blood, because you might have gone to a nearby clinical lab, where you maybe give your details, I mean, phone number, everything, and address maybe sometimes, or at least your phone number and email address, from which, right, this insurance companies came to know that you have a high BP, right? How that will happen? So there is a data trade that is happening. Now it is not the crude oil business, right? So that is why we call data is the new oil, right? Earlier the costless resource was the oil. Now it is what? Data. And I'm not going into deeper about what is data, because these definitions you will be knowing. Data means everybody says raw facts, right? Why it is raw facts? Because there is something lacking. What is that lacks? We call it as a context, right? In data, the context is missing. That is why we cannot get more information, more things from data. You have to process it. When I say data processing, what will happen? You will be adding more context to it, right? So that the data will become highly useful. And that is why we call it as what? Information. So now the data will become what? Information. The moment you get the information, you started asking a lot of questions. The more and more questions you ask, the more and more insights you will be getting, right? So that will be your what? That is called the knowledge, right? You are deriving knowledge from information by asking a lot of questions. You might have collected a lot of sales data about a company. If you keep the data like that, will the data tell the story to you? No. You have to torture the data. The more and more you torture the data, the more insights the data will be telling you, right? So that is called what? Knowledge. So most primarily you will be asking questions like how, or starting with how, what, why. These kind of questions you will be asking, often asking to what? Information, right? You have collected the company sales data, you're asking, okay, why the company sales has gone down in the last quarter, right? How I can improve the sales of my company, right? Those kind of questions you will be asking, and then what will happen? Your information will be converted into what? We call it as knowledge. If you derive knowledge and if you keep the knowledge with you, nothing will happen. You have to apply that knowledge. When the knowledge is applied, it is called what? Intelligence, right? So make sure that you understand the difference. I mean, there is subtle difference between these four terms, like the data, which is raw. When you add context, what you will get? Information. When you ask questions to information, what you will get? You will get the knowledge. When the knowledge is applied, you can say you have applied a knowledge for decision making, right? So that is very, very important to understand. And this is a kind of a, right, the pyramid structure where it is organized. Data is facts and figures, not organized. Information, it is categorized and condensed data. You have knowledge, which is organized, and you have intelligence at the top, right? And there is one more thing that you can say, like there is something called a wisdom, the ultimate level of the hierarchy, wisdom, right? So now the type of data around us. What are the types of data around us? There are three types of data around us. You might have heard this, right? So one is called the structured data. Second is called the semi-structured data. The third is called the unstructured data, right? You know, which type of data will be more a percentage contributor to the world? It is unstructured data, because take any example, right? Take any example, I mean, famous example that, or famous applications that we are using on a daily basis, which contains or generates unstructured data, right? The voice, I mean, my voice is getting recorded, my video is getting recorded. That is an example of unstructured data. Why unstructured? Because without further processing, you cannot use the data, right? That is unstructured. There is no proper structure, right? You cannot take the video, right, or the audio directly and store it in a database. You cannot do that. You have to do a lot of pre-processing. In the same way, the blog articles you will be publishing, the web pages that you are seeing, the PDF ebooks, all these are contributors to what? Unstructured category, and that contribute to 80 to 90% of the data getting generated globally, right? That is where a lot of data related the job profiles are getting created as well in companies, right? We often say data scientist is the sexiest job of the 21st century, that we often say, right? So why it happens? Because we need a lot of people to process data, right? To process the data, to get the insights from it, then use that for the decision making purposes. The structured is very, very easy to work with. Why? Because in the structured data, you have a proper structure. You might have heard about SQL, right? What is SQL? Structured query language. Because you are storing data or the data is getting generated in a structured form. Let's say you have your company or your institution is using an ERP, right? An academic ERP or maybe a CRM or whatever it is. The data is stored in a proper format, in tables, in rows and columns, right? That is why it is called a relational database, RDBMS, relational database management system, where you have a language to communicate with. What is that language to communicate with? That is called an SQL, right? You can easily store, easily retrieve, right, from the structured data. There is a semi-structured data. What is that semi-structured data? Can you say an example of a semi-structured data? Yeah, CSV to some extent, yes, CSV. Then, have you heard of XML? XML data. What is XML? Extensible markup language. What is the difference between HTML and XML? Exactly, wonderful answer. One, it is predefined. Which is predefined? HTML, it is predefined. You want to make a paragraph, you have to use P tag. You cannot use P1, P2 tag. There is no P1, P2 tag in HTML, right? If you want to give the font a specific size and color, you have to use font, right? So that tells you how the information is displayed, right, in the web page. So you don't have a flexibility to change the tag defined in the HTML tag set, right? So, but in XML, that is one of the, most widely used data exchange platform. We call it as EDI. What is EDI? Electronic Data Interchange. So EDI, Electronic Data Interchange, used it to interchange data between systems. So people were using XML to represent the data and exchange this data between systems. But in XML, what happens? You can define your own tag. You can define your own tag. For example, if you are representing students' information, you can have STID. What does it mean? Student ID. One person can represent it as STID, the tag. Another person can represent SID. Right? It is up to the person who create the XML file. But you have to follow certain structure. If you are opening a tag, that should be closed. Right? If you have a hierarchy of tag, that needs to be properly indented or aligned. Those are the rules or structure. But that is not sophisticated as structured data as we have seen in the tables and rows. Right? So that comes in the middle category, that is semi-structured. Unstructured data, it is a real culprit because it does not conform to any standard. You have to do a lot of processing to convert that into structured or semi-structured, then only you can unearth the information from it. That is why it is challenging, right? So 90% of the data, there is a statistics that says that 90% of the data that is, that we see today around us was generated in the last few years, right? So what could be the reason? One of the reasons, the major share has been generated in last maybe 1 decade. Because of course you can see the rapid developments that are happening in the ICT world. What is ICT? Information Communication Technology world, right? So more and more systems are getting digitized, right? Earlier there were, everything was recorded in a pen and paper kind of a register. Now, you cannot literally see in registers in at least in some government offices, still it is being there, but still majority of the cases, it is converted to what? The digitization. So of course, digitization means what? Your data is getting digitized, right? So the number of data or the quantity of data generated day by day will be increased, and 90% of such data would belongs to, the category where it is already unstructured and has got generated in the last few years, right? So that we term, the fancy term that we would be calling for such a larger data set would be the big data, that again you might have heard, right? Big data, where the data set size is very, very huge. Your traditional programs cannot process it. So you need to have a cluster of computers, a collection of computers to process it distributedly, right? In a distributed fashion. That is big data. Now we are slowly moving to the world of NLP, natural language processing. Just keep all these definitions in mind, because we will be using this maybe after some time, right? What are the major terms that we have learned now? not NLP, that you haven't started. Yes, the data, information, knowledge, intelligence, wisdom, types of data, semi-structured, structured, unstructured, and we have seen that 90% of the data that has got generated in the last few years. Yes, you all are wonderful. You are listening, right? At least I could see some, right? I mean, I could hear some responses. Nice. Keep this up. Now we are moving with the NLP, right? If I'm asking a couple of questions about NLP, just like I know everybody have used the chat GPT, right? Students might have used for generating assignments, right? Don't right, say that to your teacher will be killing you. Then the teachers might have used it for generating some question papers at some time, right? Or else to develop some, right, some sort of syllabus or curriculum, or at least for searching something, right, related to academics. Industry persons might have used it for code generation. So there are plenty of use cases that you might have already used in AI systems, but without knowing what exactly happening at the back end, right, of ChatGPT, or what it, I mean, where it belongs to, what sort of application it is, right? So that would be the one of the examples of NLP system, right, where the natural language is being understood and processed. And before that, what is natural language? Why it is called a natural language? What is natural language? Human understanding. The language that we speak and write is called the natural language, right? It is not necessarily be spoken language. It can be the written language, the text as well. Those belongs to what? A natural language. So if I'll be asking the question, right, you might have used all the services, right? The Google Translation, at least you might have tried. The second could be the virtual agent, that you might have seen that agent is popping up from the bottom right corner of a web page and asking, hey, how are you doing? How may I assist today? You might have seen at least one such agent. And you might have used a spelling or grammar correction tools, specifically the Grammarly, that everybody is having a Chrome extension added to their page, and so that you can read content, I mean, correct the typos and suggest words and so on. Again, it's a premium service, but still, I mean, it's a freemium service. It's not a premium one, it is freemium. Some components are free, but again, you have to pay. Whatever it is, all these services are having a component called the NLP at its back, because it is understanding natural language. When it say the Google translation, what happens? It will be converting from one language to another. Meaning you have one language that is providing, that is your source language, and you have a target language to which the responses are generated. Right? So that uses natural language, the human language that we speak. The second would be the virtual agent, as I have mentioned, right? If there is a airline reservation system, right? Or else now there is in IRCTC, I know you might have seen, right? There is Ask Disha. Disha is the chatbot name, where you can even book a ticket, right, without going to the search window. Like you can interact with it and get the ticket done. But many of the time there are glitches, as it is IRCTC. But earlier people used to say the best method to test a person's patient level is to give him a BSNL connection and the IRCTC website and ask him to book a connection, book a ticket, so that you can quantify how much patient he is. So now there are things have been changed. Even IRCTC is having this kind of systems where you can interact with it and book the ticket. So that is kind of a virtual agent. Again, you are conversing in natural language, right? So the moment you say, like, it will be asking, right, for which date you want to book the ticket. So you have to type a date. That is in a natural language, right? So this is again another application of NLP. Then spelling or grammar, obviously it is reading and understanding your text and then suggesting grammar changes, right? The typos being corrected. So all this uses something called an NLP, that is natural language processing. Now the question, what is natural language processing? Any random definitions, or tell me your understanding about what is NLP? In which circle it fits into? Which category it fits into? It's a subfield of AI. Subfield of AI, artificial intelligence. What is artificial intelligence? Human-made intelligence, good. Very short answer then. Ability of a computer to take decisions, yes. Interesting. Everybody knows some definitions. I'm very sure that AI means different definitions to different people. If you're asking that to a 7-year-old kid, he will be saying like it is all about walking robots, right? Because that is something that they are relating AI with. And for me, AI is something different, and for you, AI would be something different. So there is no cliche definition for AI, even though many sources discussing many things about AI. But computer science people will be saying AI is a branch of computer science, which is not true, right? Because AI is not a field of computer science alone. Of course, it has some concepts derived from computer science background, but AI is more than that. So we can maybe in a rough way we can say like AI is an interdisciplinary field which draws conclusions and information from different sources. I mean different areas such as optimization, mathematics, right? The probability and statistics, anthropology, psychology, sociology, linguistics, right? So all this, I mean, there are many other subject areas from which this, the ideas are being taken for AI. So we can say AI is an interdisciplinary field where it's the study primarily focuses on making the computers, right? Making the computers think or act like humans, right, in general sense. And for that, even though the definition looks simple, the effort to do that would be very, very difficult because, you know, computers are just electronic devices. We say computers are dumb machines, right? Why dumb machines? Excellent. Until the human gives some instructions on what to do using some program, the computer will be maybe a hardware that is sitting maybe on a desk or in a corner of a room. If you are buying a computer, keeping it in your study room or in a lab, maybe will the computer get bored and after some time when the computer start working or writing program is on? No. You have to tell the computer, right? This should be done. This is the software that you have to execute. These are the programs that you have to execute. So that is a bit complex. That itself, writing programs and making instructions to do something using a computer itself would be a bit challenging. Then now we are talking about a system, right? A area where human-like intelligence needs to be given to a electronic device, and that would be a bit challenging. So that is what AI will be addressing. In the last decades, there are several progress that has been happened, right? Several humanoid robots were developed, right? So can you name one famous humanoid robot that comes to your mind? Sophia, yeah, cool. Sophia, you might have seen that video, right? Sophia is interacting with the people, right? And which country has given the citizenship to Sophia? Not US. It's a Gulf country. I mean, the GCC country. GCC country. No. It was, yeah, Saudi Arabia, right? The Kingdom of Saudi Arabia has given the citizenship to first, right? The Sophia robot as well, right? You can think about how this is going, right? So, and another thing is that many countries are having now minister for AI. You know that many countries are having, especially UAE. They do have a minister who is focusing on this AI related developments alone, and many countries are following that as well, right? So that is the moment in which AI growth is now happening. And India, in the last union budget, what was updates on AI? Is there any updates on AI? Something happened? What was the recent LLM that got introduced in China? DeepSeek. So you're following news, yeah. Then what about India? You know what is happening in China, but you don't know what is happening in India. Yeah, strange. Yeah, but some developments with respect to LLMs is, I mean, FM Finance Minister has announced something. Yeah, they have announced that they are going to heavily invest in the AI developments. I mean, capability building and then LLM that needs to be developed. I mean, chatbot. I mean, chat GPT kind of things that needs to be developed exclusively for India. right? So whatever the issue with us is that whatever the Western world is doing, that we will be following, right? So we are using right what ChatGPT, right? And we don't know, can we build something for India, right? There are, I mean, early interventions that are happening. I'm not forgetting that, but still, uh, we need to think about a chatbot that is exclusively developed for India according to Indian culture, Indian context, and so on. So that is something that announced. I was just checking the DeepSeek case, and there were a lot of controversies that are happening in the with respect to DeepSeek as well, right? US has right, at least US, not complete US, but US Army and Navy, that they have shared in X, the Twitter platform, that they are blocking DeepSeek because DeepSeek is against their policies and kind of things, and nobody working in the army can use, I mean, at least in the US, cannot use the DeepSeek. Of course, we will come to the reasons later when we talk about the ethics and those kind of things. But why NLP? NLP, because as I said, more than 80% of the data is in unstructured form, right? That is either written text or the other forms of unstructured text, right? It can be the speech signals and so on. So that needs some sort of analysis before you convert that into a structured data or to build some intelligence. It can power many applications such as language translation, question answering, etc. NLP will be helping you to extract insights from emails of customers, right? Their tweets, text messages, etc. For example, there is a customer care right division of a company, where earlier what we were doing, we will be sending an email to them. They will be reading the email manually, then responding, right? So now there are ML and AI systems which can segregate this email based on the pattern. Based on the pattern, the email will go to the appropriate person, I mean, appropriate buckets, and they can quickly say, and sometimes even the machine can write a reply and send to the person. So those kind of applications require some sort of natural language understanding, because email is an example of a natural language, like you will be writing it in a plain English, right? So that needs to be analyzed by a computer. For that, you need what? NLP, which is a subfield of what? AI. AI in general sense, it's a broader umbrella that deals with making machines think and act like humans, where NLP will be a sub area in the AI umbrella, where it will be dealing with what? To understand the human languages, the natural language, right? And inside this NLP, now there is there are subfields, right? Generative NLP, people will be saying, or in the AI spectrum, there is a subfield called the generative AI, right? And machine learning is again a subfield in what? AI. Inside the machine learning, you might have heard there is deep learning, right? So there are, I mean, newer and newer things that are happening in this broader spectrum of AI. And natural language is equal to human language that we have seen. I mean, the success in terms of understanding the language is there, but still there are a lot of improvements, a lot of things to be done, because let's take the case of linguistic diversity. Now most of the application developments and success are being focused for what we call it as a resource heavy languages. Resource heavy languages, let's say English. If you check most of the data sets, most of the applications that are being developed, that are focusing to English, right? And some languages like the Chinese, and there are developments on Arabic and so on. But take the case of India, right? One of the most culturally rich, the linguistically diverse country in the world, right? Where you have a different language for almost all the states, even though some states will be sharing the common languages. But right, I come from a state where we will be speaking Malayalam, right? And there is Tamil, right? There is Kannada, Telugu, Hindi, Bangla, right? How many languages are there? All these languages needs to be understood by the machine to have a locally sensitive applications, right? So that is how the digital divide that is happening. Maybe ChatGPT can be accessed by anyone. Maybe it can be accessed by even the farmers. I'm not reducing the significance for farmers, but at least, I mean, they can also use ChatGPT to search what fertilizers should I use, what is the month of cultivation for this crop, and so on, Now they cannot do that. Why? There is a digital divide. Why? ChatGPT primarily works in English, right? And most of the time, the farmers are not having their smartphones, right? Even though we say the smartphone penetration is higher in India, that is not true. I mean, in always all the sense. Think about a situation where you can develop an LLM or develop an NLP application, a question answering system or a chatbot kind of a system for assisting the farmers in their language. There are interventions that are happening, but that is not a full swing. So that is where I told this, there is a limited success with respect to the linguistic diversity. It is not just about the English language or the common language where we will be developing applications, right? So for other languages, you need a lot of, those are called the, the low resource languages. The other languages, not the high resource, we say like there are the plenty of resources which are available to train the models. Because when you do research, if you are researchers, I mean, there are researchers out there, when you do research, what would be the path that we will be following? Mostly due to several reasons, we will be taking data sets which are in English, right, to develop something. Why? Because there are plenty of papers getting published in the English language. There are plenty of research work that has already been published in English, so that it is easy for you to get the data and to start working with something, right? So you have to follow the other path where less number of people have traveled, right? So obviously it is very, very difficult. I mean, some of my efforts in training some LLM with Malayalam, what happened? The resources and data sets for doing that is very, very limited. So we have to sometimes start from the scratch, right? Anyway, for a PhD where the time is restricted, you cannot do that. You cannot spend all your 3 years in, getting the data collected, pre-processed and made it in the tokenization. I mean, that will not be doing. So obviously you will be going with the path where everybody is traveling. So that is something that we need to look into. Right, region-specific languages, context and culturally sensitive applications and research methods and things needs to be developed. Right, that is something where you can focus maybe from a research and application development perspective. How is natural language different from computer language? We know natural language is the language we speak and write. Computer language is something that is written in some programming language. Then only the computer can understand. Some of the challenges with respect to the NLP would be, let's take the example. Obviously, the first case, it is dynamic. NLP is dynamic, flexible, ambiguous. Right? Take the case of first example, a famous example where the dynamic or ambiguity will be explained in the context of NLP. I am going to the bank. Let's take the sentence. I am going to the bank. So what will you mean by or what will you understand, I mean, by this sentence? What will you understand? So let's take the case of bank, right? The term bank. Bank is having different meaning, right? It can be the financial institution or else it can be the bank of a river. If a person randomly walking beside you is telling like, I'm going to the bank, what will happen? What context? If he is carrying a passbook, right? Or else if he is telling like, I'm going to the bank to deposit money, right? Then you will understand he might have referred the bank with a financial institution, right? Otherwise, there will be an ambiguity, right? There is a duplication in the sense, in the meaning. That is again challenging. So understanding the context is very, very important. That is why I used the term before, context. When it comes to data, context is not there. You have to add the context. Now, if you're adding the context, I am going to the bank to have a picnic. Let's say I'm going to the bank to have a picnic. So what is the catchy word there? Picnic. On seeing the picnic, that is the context, you can relate that, okay, he is going to the bank of a river. Anyway, you will not be going to a bank and have picnic, right? No. So that is the context that you will be adding. So the second, I saw the girl with the telescope. What do you mean? There can be two possibilities, right? What are the possibilities? You were using a telescope and you saw one girl. There can be another possibility. You saw one girl who is holding the telescope. So think about the ambiguity now, right? Even humans are facing the ambiguity challenge here on hearing this term. Then let's forget about the machines. Making the computers understand this ambiguity or ambiguity-free language is very, very difficult. right? The second example. And often the human languages, we always take the shortcuts, right? We will not be saying a complete sentence formally every time, right? So usually there is a in the social media itself, right? There will be a lengthy message somebody else will be sending. We will be just saying right? We will be saying K. We are even right, lazy people to type O and K. We will be just putting K or HM. That means we understood it. In the same way, there's a natural tendency for humans to write a shorter messages. And in most of the cases, the language communication is not very formal as well, unless we are sending email to a professor. I mean, if you are chatting between friends and all, we will not be formal, right? So we will be using, we will be saying to work we go to work, right? So whatever there is, we go work. So all this will be in a informal sense, carries the same meaning for us. So that is again challenging and nice. I mean, some words will be having multiple meaning, right, in English. So these are the difficulty in making the computers understand the natural language. These are not just the difficulties, these are some of the major difficulties, right? So now this is again all the case with English. Now for every other languages, there are plenty of other rules to be satisfied to make it understood by a computer. Now you can imagine the challenge the NLP world or the AI world is challenging, I mean, facing to make such applications, right? So there are a lot of developments that are happening with respect to English and resource heavy languages, and low resource language is something that you can always check for, right, to make some socially relevant applications. So in conclusion, getting computers to understand the natural language is hard. It is really difficult. There are some successes, but all those successes are focused towards, right, some languages, right, some languages, and there are plenty of other languages. Even some languages don't have letters, right? Some languages they will be speaking, but there is no right script for writing, right? So that is also there are challenges. And some of the differences, maybe you might have seen all these definitions, right? Computational linguistics and NLP, people will be interchangeably using these terms, but these two are different. Even though there are overlaps, these two are different. What is computational linguistics? I mean, what is linguistics? It is all about the languages, study of languages, that is linguistics. So if you are using computational techniques to understand or to analyze the language components, then it is called a computational linguistics. There is no natural language processing that happens per se, right? So NLP is a bit more in the processing side. So in the computational linguistics, it is the aspect of human language faculty where the linguistics deals with how we humans acquire language, how we communicate, how we differentiate between words, right? Just like how a child acquire the languages from the environment he is growing up. So that is computational linguistics, basically the statistical or rule-based systems primarily. It will be the combination of linguistics, cognitive science, and AI primarily. Then there is natural language processing, as we have seen, ability of computer programs to understand and generate human language utterances. It comes from computer sciences, AI, human computer interaction, or HCI, human computer interaction. Then people will be using human language technology, or HLT as well. Human language technology is kind of it's a broader one, in which we can have computational linguistics or plus NLP. But these are the terms people will be often using interchangeably, right? NLP, computational linguistics. What NLP can do, some of the applications, we will be quickly going through these applications. One you might have already seen, machine translation. What is machine translation? Using a machine or a computer to translate from one language to another. One language to another, most importantly, while preserving the meaning. Because if you are taking individual terms from a sentence and you are converting that into another language, looking at a dictionary is not a machine translation, right? So what I just said, you have a sentence. You are taking individual words from the sentence. You are looking at a dictionary and converting that dictionary, individual terms, into other language is not a translation. Why? If you do so, the meaning will be lost, right? So you have to get the meaning, you have to convert from one language to another and while doing that, you should preserve the meaning, right? So, and also you need to ensure that the output is grammatically correct, right? There are a lot of right systems, and Google Translate is the best example that everybody will be using. But still, for some language pairs, Google will be failing. That you can try out. There are several language pairs. Google will be incorrectly translating things. Google itself is learning. There are many people working behind the Google translation systems to make it correctly work. And information extraction, another area where if you have a natural language text or let's say a speech or whatever it is, you can get some information from that. That is called the information extraction, IE, which is a subfield of NLP. What is information extraction? As the name implies, extracting information of relevance from a text or a speech or whatever be the natural language. Example, John stays in London, he works there for Polar Bear Design. On looking at the sentence itself, we can see that John is a person and he works for an organization called Polar Bear Design, right? So we know from our intelligence, it is an organization, it is John is a person and London is a country or a location, right? But for computers, this is just kind of a some bits and pieces, or I mean zeros and ones, or those kind of data from which how we make the computers understand. Okay, John is a person, London is a location, he works there for an organization called Polar Bear Design. This is called information extraction. And if you do this information extraction, you will be converting them into what? A knowledge base. What is a knowledge base? What is a database? Collection of data organized in some form. What is a knowledge base then? Collection of knowledge. So from where will you be collecting this knowledge? You have to build it from a source document, right? Or a source data set where you will be extracting all this information, putting in some place. What is the use of building a knowledge base? You can build n number of applications using the knowledge base. You can have a question answering system, you can have a summarization, you can have information extraction, whatever be the use case, you can use this. So after this information extraction, what you will get? John is identified as a PER. What is that? Person. The tag, we call it as tag. And live in London. London is a location. So if a question answering system needs to be developed, which is asking the question, where does John live? Obviously, the answer is in the knowledge base entry. Where it is? The location is London. And another knowledge base entry it has extracted is John, again a person, employee of, that is a relation, and Polar Bear Design is an organization. If you are asking where does John work, obviously you will get the answer what? Polar Bear Design. Right? So this is what a knowledge base construction from unstructured text, which is a well-studied research area. Right? All the companies like Microsoft, Google, all of them are having a knowledge base, right? To improve the search experience, to improve the customer experience and so on. And at the back end, sometimes we will be calling it as a knowledge base. Sometimes we will be calling a broader category is called the knowledge graph. Knowledge graph. So NLP, knowledge graph, text mining, this is again another promising research area maybe you can look into. Building knowledge graph. Because at the end, every information is represented in graphs. Right? Whether take your case of social media, right? Social media data is the best example where the data is represented in a graph form, right? Why graph form? How the friend recommendation comes to you? Friend recommendation. If you are connected with a person and that person is having a friend, obviously there is a link that gets established between that person and you. And you will get a recommendation. Hey, seems like you know this person. Will you be adding as a friend in Facebook, right? So that is a graph kind of a mechanism. Social media itself is a large graph, right? So that is something, right? A knowledge graph that you can mention. Maybe some of the terms that I'm just telling, you can note it down so that you can do some research, or in the future, maybe you can do some research as well. And if you will be asking the question, what is another example for IE? For example, you might have got this kind of an email. Please be informed that there will be a staff meeting tomorrow, or there will be an employee meeting tomorrow, or there is an event that is happening tomorrow, and so on, right? So in most of the cases, what will happen, this tomorrow or the date or the time, this will be automatically extracted, and Google will be asking will you be adding this to a calendar, or should I add this to the calendar? So how Google knows this is a date or this is the location in which the event is going to happen? Because IE algorithms are working at the backend, right, and extracting and giving you the suggestion. And this is called a named entity extraction. Again, another area, named entity extraction, or in short, we will be calling it as NER, where named entities will be extracted from this text. So, which is called the proper nouns like person, location, organization, date, currency, right, monetary values, or these kind of information will be extracted. Again, the same example, John is a person, stays in London. London is a location. He works there for Polar Bear Design, which is organization. And if there is a sentence, John earns maybe 2 lakhs per month, that 2 lakhs will be going into what? A monetary value, right? Money tag as well. So you can extract these kind of personal, the proper nouns from a text. This is called the named entity recognition, which is again working well for English and some other languages. If you take the Hindi language and try to do the NER, or else the Kannada language and take NER, that will be failing. Why? Because the most of the developments algorithms will be having a favor towards the English language. Now, this could be another research dimension you can look into if you are interested in NLP. Can we build a named entity recognition system for Kannada? Right? Obviously, if you give the sentence in English, like Kristu Jayanti College is in Bangalore, Kristu Jayanti mostly will be identified as an organization, Bangalore will be location, but that is an English one which the system was trained on. If you are taking maybe a poem from a Kannada literature and giving to the AI to detect the NER, that will not work. Right? Because those terms are not familiar to the computer. That is something where you can look into. Then the co-reference resolution. Co-reference resolution in the sense tracking back named entities is called a co-reference resolution. Because take the example, the same example, John stays in London, he works there for Polar Bear Design. Right? So there are two terms. One is he and the second is there. He and there. Right? So as a human, we know he refers to whom? John. There refers to London. Right? So we know that, but computers does not know that. So tracking back these named entities is called what? Co-reference resolution, which is again for English, there are some success. For other languages, it is almost zero, at least for Indic languages. Right? So that is, bit challenging to train this, co-reference resolution. But again, that is again an area worth looking into for Indic languages. So you understood this example, right? He and there. We humans know he refers to John and there refers to London. But making it computers to understand he and there would be challenging. Question answering, another area for NLP. That is what the ChatGPT will be doing. You will be asking a question, it will be generating an answer and giving to you. Another one, the same example we have seen from the knowledge base, we will be taking what? We will be taking a question, we will be asking the question, where is Polar Bear Design located? Obviously, the answer would be London, because from the entry, from the knowledge base, the system will be checking and giving you the answer. Then plagiarism and paraphrase identification. Maybe the student community may not like this application of NLP, the plagiarism detection, because the students may be copy pasting content and presenting that to the maybe the teachers, or sometimes they will be giving it in the publishing it. So what is plagiarism? Plagiarism is a similarity level with the existing content. If you are taking the existing content and presenting as your findings without citing the proper references, that is treated as a plagiarism. So plagiarism detection and paraphrase. What is paraphrasing? Now with this ChatGPT, paraphrasing is also very, a hot topic. What it happens? So there are AI detection systems, as you know, right? There are generative AI systems. The systems which can identify the text is generated by ChatGPT or any sort of AI agents. For example, there is a Turnitin. Turnitin software is a software used for plagiarism detection, but now they do have an AI similarity detection capability as well. Even though they give a warning, we cannot blindly say that there is a AI similarity level for Turnitin, so that the document might have been from AI. We cannot be very sure, because Turnitin itself is giving some warning that there can be false positive in the sense that need not be written by generative AI, but still they are developing some algorithms in the backend to understand whether this has been generated by ChatGPT or any other component. So to avoid that, what we will be doing, something called a paraphrasing. Have you heard of a tool called a QLBot? At least, yeah. QLBot, what is it exactly will do? It will be doing the paraphrasing. What you will do, you will get a text generated by ChatGPT, copy paste it in the QLBot, and you rewrite it while preserving the meaning. But the sentence, the words will be different, the arrangement of words would be different, right? But it preserves the meaning. So that is something that is called the paraphrasing. So plagiarism and paraphrasing is something which is again another example of NLP application. Again, the most popular one, everybody tries out with some application which is called the sentiment analysis, right? Sentiment analysis, opinion mining, opinion identification, emotion analysis, more or less the same terminologies, but what exactly it will do, it will be quantifying the sentiment of a sentence or the sentiment of the text, whether the customers were thinking positive about a product or service, it's negative or mixed opinion, okay opinion, all this will be detected by text. So we will be writing Google reviews a lot, right? Google reviews, or else when we write maybe or purchase some products from Amazon, we will be writing reviews, right? So that is primarily in text, and this text needs to be understood and identified. Why? Because for the companies that is very, very important. Company wants to improve their products and services, and from whom they will be getting the feedback? From the customers who might have purchased or used their service. So they will be obviously writing. So the companies, like, if there are millions of people will be writing reviews, or 1,000 or 10,000s of people are writing reviews, it is very difficult for a human to read each and every review and give, to get it summarized and so on. So they will be employing something called a sentiment classification algorithms. That is again another application area for NLP. There are speech recognition, speech synthesis, and voice recognition applications. That is again area of NLP. Speech recognition, primarily we call it as a STT, what is called a speech to text. STT, speech to text. And speech synthesis basically known as TTS, that is text to speech. Text to speech. And voice recognition or a speech recognition is different. Speech recognition is different from this speech synthesis and recognition, because in speech recognition we have to identify what exactly the word the user has uttered. For example, when we will be speaking very fast, we can say like maybe I will be saying Dubai and goodbye as in the same modulation, right? Dubai and goodbye. That may be something similar. You may even get confused, right? Whether I have told Dubai or goodbye. So that needs to be identified. What exactly the user has told. That is called the speech recognition, right? You are identifying the speech, and there is voice recognition systems for access control and so on. That also uses some NLP applications. Another application would be the topic modeling. So I'm just throwing out different application areas so that you can look maybe later, and we can even have a discussion if you're interested to have a particular area and you want to know more about it. So that maybe you can do some NLP applications maybe later. So topic modeling is again a promising area in NLP, where, for example, if I'm giving you a document to all of you and asking you to tell me the topic of discussion in this document. So for a single document, it is easy for you to go through the document, understand it manually, and say, okay, this document is talking about computer science, or this document is talking about biology, or this document is talking about maybe AI. That is easy for a single document. But if I'm giving, say, 100 documents, 1,000 documents, 5,000 documents to you, and asking you to tell me the topics of discussion for this kind of these documents, what you will be finding it be difficult, because you cannot manually go through each and every line and understand the documents. So for that, we do have an suite of algorithm called a topic modeling, right? So you can just throw the collection of documents to the computer and the computer will be able to run some algorithm and gives the topics. Topics are nothing but collection of words. Topics are collection of words. So that is also possible with the NLP and machine learning. So you have a collection of documents here. You have a topic modeling algorithm here. You have certain topics that are generated here. So this is again another interesting area in NLP or machine learning, which is an unsupervised learning algorithm. Topic modeling. So so far, how is it? You could relate some of the applications, right? Where you were using some application without knowing NLP is right there in the backend, right? At least we have seen some of the applications. We have seen the very basic, right? The fundamental things about the data, information, knowledge, intelligence, and so on. We have seen NLP as a sub-area of AI and how NLP is going to help in the problems related to maybe in industry, academia. Whether only the data matters. The algorithms that you are applying that remain same, right? So so okay, the pace at which we are moving. Yes. Okay. Now we will take a short break. Yeah. And
Now we have a short break, 10:45 to 11. Please come sharply like now.
we have a lot of things to learn. So please come back. Because you have got an idea. Stop word removal, we have discussed, right? Some of the stop words could be the, is, and, of, in, which is not needed. You can eliminate, you can remove it from the text. Next is POS tagging, again another pre-processing technique. What is POS? Parts of speech. What are parts of speech? Every word will be having its corresponding parts of speech, right? So it is called a POS. Sometimes you have to do the, right, for example, I think there is a issue with the PPT, but the sentence is the cat is sleeping, right? The cat is sleeping. The will be the determiner. The cat will be the noun, right? In the similar way, each and every word will be allocating a parts of speech, which is also needed. For example, if you are combining certain words, as I said in previously, there is a word called a supercomputer. What is the parts of speech for super? Super. Computer is noun. Super, it is adjective, right? So there is a pattern. If you combine adjective and noun, you may get a complete meaningful word. There is a pattern, that is a rule that people were using to create meaningful words out of a document. So you need a POS tagging. NER we have seen, right, previously, identifying named entities, categorizing them into person, organization. This is again another pre-processing technique. Named entity use cases we have seen, news aggregation, customer support, for research, for legal document analysis. You want to analyze the named entities like the judge, the name of a judge, the name of a court, right? The place where the court is situated, the judgment date, right? So these kind of entities you can extract using named entity recognition. Now, the natural language processing techniques, the algorithms that we are talking about. So this is how, look at the figure. This is how the categorization happens. You have a large circle which is called the artificial intelligence. Inside that, what you have? Machine learning, and inside that you have deep learning. But when it comes to the data science, it is kind of an overlapping, right? So data science is kind of a house where you are talking about data analytics, for example. Data analytics is a room in the house, right? Similarly, data science is having, right, all this will be having applications in the data science domain, which is a generic one, which deals with any sort of data analysis, right? So just keep this in mind. What is ML? What is ML? Subset of AI that deals with making computers understand, right? Making computers understand, or training the computers with a lot of data so that at some point in time, the machines will become what? Intelligent. Intelligent in terms of what? When you give a new data, machine can recognize it accordingly. For example, if you are training a machine learning for sentiment classification, right? You have collected a lot of customer reviews and you trained an ML algorithm, right? What will happen at the end? Even if you are giving a new review, the machine learning model will be able to classify it into positive, negative, or neutral. Right? You are building a news classification system. You have collected a lot of news articles and trained an ML model. What will happen at the end? Even if you are giving a new news, your model will be able to classify. So from where it is getting that idea of classification? From the data you have given, from the algorithm that you have trained. Right? So that is machine learning. Type of machine learning, I hope you are right familiar with this, right? Supervised learning, unsupervised learning. For supervised learning, there are classification and regression algorithms. When you use classification and when you use regression, yeah, input and output, but for regression also there is input and output. It depends on the target variable, right? What needs to be predicted? If that needs to be a continuous value, right? For example, you want to predict the sales value of a company, right? Let's say 20 million. That is the value that you need to predict. In that case, which algorithm you will be using? You will be using regression, right? Regression. If the target variable is categorical, meaning sentiment classification, right? What are the categorical values? No, category, I mean the categorical values in the target variable. What needs to be predicted? The sentiment needs to be predicted. Sentiment can have different forms, right? Positive, negative, or neutral, right? That is categorical value. The news classification. What are the categories there can have? Categories of news. Maybe finance, sports, tech, right? Those are categorical values, right? So for that cases, you will be using what? Classification. If it is a complete value that needs to be predicted, it will be regression. There are plenty of subcategories of algorithms as well. And there is something called an unsupervised learning. What is unsupervised learning? You don't have the target variable. You don't have the labels. At that time, you can just put the values in the algorithm, set some parameters, and you can start running. What will happen then? Machine will try to understand, right, the differences and patterns and segregating the data accordingly. That is called the clustering, right? So if you want to cluster maybe the customer data, you don't have to have a labels. You can just put in some clustering algorithms like k-means or hierarchical clustering algorithms, where the algorithm itself will be executing and finding out the patterns for you. That is clustering. Now, the feature extraction from text. What I just said before, the feature extraction, feature meaning the important things that you want to make the machine learn. That is feature, right? So features, right? We were discussing about the text data, and the text is not directly understood by the computers. You have to convert that into what? Numbers, right? You have to convert that into numbers, then only the numbers will be understood by the computer, right? So these parts are very, very important. This is one of the approaches, we call it as bag of words for converting your text into numbers, right? Why we have to convert the text into numbers? Because we already learned that human language is not directly understood by the computer, right? Computers can only understand numbers. So how will you convert or encode? How will you convert or encode the human language or the natural language into a machine understandable numerical format? That is called the feature extraction or feature encoding in terms of NLP and machine learning. So one such approach is called a bag of words. What is bag of words? It is a bag containing a lot of words. That is bag of words, right? So you can see here, right? You have a document here, right? In the figure, you have a document here, and you are extracting all the words from the document by using which technique? Extracting all the words, splitting it into words, tokenization, right? Tokenization. You do the tokenization, you put all the words in a bag. Similarly, for all the other documents, you are doing the same thing and putting the words in this bag. Now, what you are doing, you are just counting how many times a word is occurred in the bag. Let's say the word it is having 6 times, right? The word I is having 5 times, the is having 4 times, to is having 3 times, and so on. So if you have the words as well as their numbers encoded like this, it is called a bag of word, right? Bag of words. For example, there are two sentences. You have constructed a bag of word from all the documents. Now a new sentence needs to be encoded. These are your sentences. I love dogs. Dogs are great, for example. Some simple sentences. In this case, the vocabulary, what is vocabulary? The words. The words would be what? I love dogs. Then you will not be repeating dogs again. The vocabulary has to be unique. Right? You are putting I love dogs already taken for from the second sentence. You will not be again adding dogs. Then are great. Right? Which are great. And now how will you compute the numerical representation for first sentence? I love dogs. You will be checking in the bag. You will be checking in the bag whether the word I is there. If it is there, what you will be putting? You will be putting a 1. Right? You will be putting a 1. If it is not there, what you will be putting? You will be putting a 0. So there are two types of bag of words. Either you can have a binary bag of words. Let's say your binary vector will be containing only ones and 0. You are just checking presence or absence of a word. But if you are counting how many times it occurred, then it is called a count vectorizer. Right? Count vectorizer. Count. You are counting how many times the word dog is there. Right? You are counting it and creating a vector, which is called a count vectorizer. Right? So this is one example. The second feature extraction technique is called the TF-IDF. Just keep this term in mind. You don't have to look, how this is computed for the time being. TF-IDF stands for term frequency versus inverse document frequency. Term frequency versus inverse document frequency. As the name implies, what is term frequency? What is frequency? How many times a word occurred? That is called a term frequency. Right? So you can obviously get the count of how many times a word occurred in a document. You can count it, right? 5 times, 10 times, 50 times. That is your term frequency. Right? Is there any challenge with that? If you are just taking only TF, term frequency, what will happen? In a document, right, there are some words, like the stop words will be coming more times. Right? A, and, the, these words will be occurring very common in a document, right? Rather than other words. So what will happen? The stop words will be getting higher frequency. Right? So that should not happen. For that, another matrix you will be computing, which is called what? Inverse document frequency. To penalize, to reduce the effect, to reduce the strength of what? The common words. Right? That is called the TF-IDF. So TF itself is okay. Right? You can count how many times a word occurs in a document, that is fine. But many times what will happen? Your stop words will be having more frequency, which is not a good approach. For that, what will you do? You will compute the inverse of a document so that the common words will get a lesser value. Right? And these two values will be multiplied. What are those two values? TF and IDF. So that it will be converted into a form. So this is how it is computed. You don't have to look into, right, the TF and IDF. This will be computed. You will be, right, multiplying this and you will get a TF-IDF value. Yeah. TF-IDF. Yeah, sure, ma'am. So TF, we have seen what is bag of words. You will be putting words in a bag and just encoding it with either with 1 or 0, binary bag of words, or else the count will be taken, that is count vectorizer. Now another feature encoding technique which will be saying the relevance of a word to a document, that is called the TF-IDF, relevance of a word to a document, right? How much the word computer is relevant to a document is known as what? TF-IDF computation. How much relevant the word machine is relevant, how much percentage it is relevant to a document, that matrix is given by TF-IDF, another encoding technique. Okay. So now TF is very simple. You are just counting how many times a term occurred in a document. That is TF, term frequency. Right? You take each and every token word from a document and counting how many times this term occurred in the particular document. Let's say when you count the words which are termed as stop words, the, a, and, right, these kind of words will be most commonly occurring in a document, right? Because those are the stop words we used to connect the words, right? So when you construct TF alone, what will happen? Your frequency for the word the will be more. Frequency for the word they, them, he, she, all these words will be ranking higher, right? Which will be encoding less information. Correct? What is our ultimate goal? Ultimate goal is to convert the text into numbers. So if you converted a text into numbers and the numbers frequency represents the stop words or something, that is less relevant. So what people have done, they have created another matrix called an IDF. What is IDF? Inverse document frequency. So inverse document frequency, you will be taking the total number of documents divided by number of documents with a particular term in it. What will happen? This will be the log E. So if you take the total number of documents, let's say 1000 by 4 documents with a term. When you are taking log, meaning you are penalizing the value. You are taking the inverse value. So obviously what will happen? The words with a higher frequency, if it is a stop word, which is ranking less because you are taking frequency, right? And you will be multiplying TF with the IDF. TF is a normal count. You are multiplying it with what? IDF. If you multiply this, you will be getting a value, and that is the TF value for a word. What does that word means? What does value means? That much relevant this word to the document. Rather than you just count how many times occurs, you will be penalizing the frequently occurring words as well. This matrix is known as TF-IDF, term frequency, inverse document frequency, another feature extraction technique from text. Right? So, see, this is an example. Maybe you can quickly go through, ma'am, if you have doubt. A document containing 100 words. Let's say a document containing 100 words, wherein the word cat appears 3 times. 100 words where the word cat appears 3 times. So what would be the term frequency? 3, but if you want to normalize it, what you can do? 3 by 100. Right? Out of 100 words, only 3 times the cat occurred. So what would be the TF value? 0.03. That is a TF value alone. Right? Now, assume we have 10 million documents and the word cat appears in 1000 of this. How will you compute the inverse document frequency? The equation is log total number of documents divided by number of documents in which the word cat appears. So what will happen? 10 million divided by 1000, which is having 4. Now your TF-IDF is not complete. How will you complete it? You have to multiply 4 and 0.03. If you multiply these two values, what you will get? 0.12, which means that 12% relevant the word cat to the corpus. Similarly, you have to compute TF-IDF for each and every word. Right? Then comes the ranking. Right? And this value will be, you will be writing in a vector form. If there are, let's say, 500 words, your vector length will be 500. 500, each and every word will be having a value. So you have to write it in a vector form. So that is called the TF-IDF vectorizer. Again, another approach for encoding TF-IDF. Now, word embedding, we are going with some advanced feature encoding techniques, which is called a word embedding. Word embedding is nothing but, in simple terms, I can say the meaning of a word or the meaning of a word depends on the company it keeps. The meaning of a word depends on the company it keeps, right? Meaning wise, like there are groups of or a word which may associate together. For example, cat and dogs may be associating together. Machine and learning will be associating together, right? So I will show the picture over here. See, if you are taking all the words and projecting it in a XY plane or in a high dimensional space, what will happen? You can see the clusters of word, right? So here refrigerator, oven, microwave, GE, LG, these will be forming a cluster. What does that mean? These are semantically similar. Meaning wise, this is similar because LG and GE are companies, right? These are the appliances. So this will be forming a group, right? And how will you compute the similarity between these two? These are vectors actually, vectors. You know what is a vector, right? The linear algebra, if you are putting a values and putting it in a square bracket, that is called a vector. So these are called the word vectors. So if you want to compute the similarity between refrigerator and microwave, what you can do? You can take the cos theta. Because vector similarity can be computed by taking cos theta. The vector 1, vector 2, you can take the cos theta. If the cos theta value between two vectors are small, then those two words are closely associated. If you are getting a larger angle, theta value for two vectors, what it denotes? These are not semantically connected or similar. So let's look at this figure. Like if you are taking the word vector for refrigerator and word vector for microwave and computing the cos theta, what will happen? This angle will be less. This angle will be less because these are semantically similar, meaning wise similar. And if you are taking the word vector for refrigerator and if you are taking the word vector for grass, what will happen? The theta angle will be more, meaning this will be wider. In the sense, these two vectors are not semantically similar. So this is the core idea in which we do have all the advanced feature encoding techniques are working, right? And this is called the word embeddings. The words are represented by the set of real numbers or vectors. You take all the words from a document, you represent that in a vector format, you project that in a high dimensional space, and you are computing the similarity by taking the cos theta between the vectors. This is very, very important because all the modern systems are based on word embeddings, right? This is how they encode. It depends on the problem that you are going to solve. This is word embedding. Is it clear from this figure? Each word is a vector. You can take the similarity by taking the cos theta. Because this is a word cluster. This is again another word cluster like kitchen, table, bathroom, vanity, sink, toilet, bathtub, faucet, shower. Right? All these are again another word cluster. These are semantically similar. Right? Here, charger, battery, DeWalt, Bosch, drill, tool. These are again a word cluster. These are semantically similar. This is how computer sees, right, the words in a vector space. So we'll be skipping this for the time being, and this is the technology. Terminology that you should keep in mind. Word to vec, because word to vec was proposed by Google. This is one of the earliest word embedding approaches. So word to vec, they have proposed this one. This is freely available. If you are developing some NLP application, you can go and download the word vec, because Google has already trained the word embeddings. You can use it in your application, right? You don't have to train it from scratch. The word embedding file is available in net. You can download it. You can pass a sentence and you can get. So not going into the architecture very deeply. There is another word embedding technique which is called a GLOVE, Glove, right? Which is developed by Stanford University. So word to vec was one of the earliest approach. Then based on that, Stanford has developed something which is called a GLOVE. GLOVE stands for Global Vectors for Word Representation, which is again freely available. If you want to generate the encoding, embedding for a text, what you can do, you can download GLOVE and use it in your application. Word to vec and GLOVE. So shall I take, ma'am, 5 more minutes to, yeah? So then this URL you can visit and you can download it, right? The GLOVE, which is a bit bulky in size, but you can download it in your laptop, because this, how they trained this, these are kind of deep neural networks. They have collected data, they trained a model, they published it so that other researchers and developers can use it for encoding the text for their classification or any other advanced applications. And see, word to vec is having two, right, architectures that they have proposed. One is called the CBOW. CBOW stands for continuous bag of words. Continuous bag of word This is one architecture. The second is called the skipgram architecture, skipgram. So what is the difference that you can see in this two figures? The continuous bag of words will be predicting one word, right? If you are giving the context, these are the context word, right? These are the context word. If you are giving the context word, CBOW, that is continuous bag of word, will be predicting the target word, right? So pineapples are, then you are putting a dash and then saying and yellow. So the right the output is what? Spiky. So how does that happen? Because these are occurring in a together in some sentences. That is how the pattern it has learned. So if you are putting the cat sat on a dash, what will happen? The output mostly will be mat. The cat sat on a mat, right? Because that might be the sentence it has seen very frequently while the model was trained on. The other architecture is different in the sense if you give one word, it will give you the context. It will give you the context. So if you are giving spiky, what it will give, the skipgram architecture, it will be giving the surrounding words, right? Pineapples are and yellow, right? So these two architectures you have to just keep in mind. So I think we will wind up this session now because we have learned enough techniques for text pre-processing and also feature encoding. Why we need feature encoding? Why we need feature encoding? I already told this answer. Anyone? Sleepy? No? Tell me the answer. Why we need feature encoding? Why we need to convert the text into numbers? Computers can only understand numbers. Computers cannot understand words. Computers cannot understand whether this is a person's name or a location or whatever, but they can understand numbers. So you have to convert the text into vectors, right? What are the feature encoding techniques we have visited so far? First one, bag of words. You will be putting all the words in a bag and you are checking. When a new sentence comes in, you will be checking if the word is there or not. If it is there, you will be putting 1, otherwise 0. That is called the binary bag of words. If you are counting how many times a word occurs in the bag, then you will be saying what? Count vectorizer. Then you have TF-IDF. What is TF-IDF? Term frequency, inverse document frequency. What is it? More robust feature encoding technique than count, because you will not be counting it, because you will be counting the relevance of a word to a document, right? So TF into IDF, TF stands for term frequency, IDF stands for inverse document frequency. You will be computing it, you storing it in a vector format. That is TF-IDF vector. What is another approach we have seen? Word embedding, which is even more robust technique for feature encoding because the words are projected as vectors. Words are, for every word there will be a vector. These vectors will be in a high dimensional space and you can compute the similarity by taking the cos angle between vectors. If the cos angle is larger, two words are apart, meaning they don't have any semantic similarity. If it is closer, it has some semantic similarity. So the moment you generate the word embedding and encode that, what will happen? The meaning will be understood, or the meaning will be understood by the vector or the computer. That is word embedding. Two word embedding techniques we have seen. What are they? Word2Vec, developed by Google. Glove, that developed by Stanford. Okay, so keep all these things in mind. Don't forget while you are having your lunch. Then come back for the hands-on session, because most of the things that we have learned will be used in the hands-on. But before we go with the hands-on, we have to learn some more architecture. So taking another maybe 30 to 40 minutes for that, then we will be doing a hands-on session. So hands-on session will be done in Google Colab, right? I think all of you are comfortable. Have you at least heard? If there are new persons, no issues. I will do a quick walkthrough on how the cells are executed, right? We will do that in the lab, ma'am, right? Yeah, we will be doing that in the lab. So we will be getting a machine, right? So enjoy your lunch and come back. Now they have another session. Okay.
Yeah, yeah. As we come to end of this insight session on transformer model in natural language processing, I would like to extend my heartfelt gratitude to Dr. Hanup sir for sharing his valuable knowledge and expertise with us. His deep insight and clear explanation have enhanced our understanding of this powerful NLP model. A special thanks to all the participants for your active engagement and thoughtful questions. No questions.
Now only we realize we.
Any questions?
Yeah, I will be around here only. You can approach me, right? You can ask.
No, right now if you want to ask any question, you can ask.
No issues.
Any doubts?
Where to use lemmatization, where to use. So that is what. If you are right, if you don't, yeah, if you're yeah, if you're concerned about the speed of the algorithm, for example, you have to process a lot of data where you don't want your right the time right to be taken too long, and also you are okay with chopping of the values. You are not concerned about the meaning of the word that is very particular. You can use the stemming. But if you are developing maybe another advanced application for NLP where you want the generated output to be a complete word, and you don't, I mean, you're okay with the processing time, you can use the lemmatizer, right? But I mean, people use lemmatizer. I mean, I found in some works lemmatizer is not that much used. They will be going with the stemming. But again, the speed and the accuracy of the value that matters for you to learn. Because lemmatizer, as I said, it is a two-stage process. It will be first generating the root word, then the root word will be checked against a dictionary. So that is why you will be getting a delay in doing that. So if you are processing a large volumes of data, I prefer to use a stemmer than a lemmatizer. Any other questions?
Any other questions?
But I will be around, like you can approach me at any time, right, before 5, so that we can have a discussion.
Thank you, sir. Okay, upcoming next, we have engaging article discussion from 12 to 1 p.m. The research paper will be discussed in the title Large Scale Discussion Making Categorization Challenges and Future Directions from an Artificial Intelligence and Application Perspective. This paper was published in Journal Information Fusion, volume 59 in July 2020. We encourage everyone to actively participate, share your insight, and engage in the meaningful discussion. Let's make this session interactive and thought-provoking. Looking forward to your valuable contributions. Not here. So we'll go to the next one.